Clean Air Tourism, an assessment of individual exposure to indoor and outdoor air pollution on the Las Vegas Strip using portable sensors in Las Vegas, Nevada. Hi, my name is Marina Vanderberg. I'll be recording the first half of this presentation along with my co-author Carlos Arambula, who will be recording the second half, both students of Nevada State College. We'd like to acknowledge Dr. Chen and Aman Jebramariam, both from UNLV. Dr. Chen lent us the particulate matter monitors, trained us on how to use them, and Aman helped us do the calibration. And a special thank you to Laura Rosales-Lagarde for guiding us through the entire project. The location of our study was the Las Vegas Strip. The Strip is a year-long tourist destination with more than 30 casinos, approximately 70,000 daily traffic counts, and more than 55,000 pedestrians. Las Vegas casinos are exempt from the Nevada Clean Indoor Air Act. The Nevada Clean Indoor Air Act protects the public from secondhand smoke, however, does not apply to gaming areas of casinos, allowing smoking and vaping in these areas. In 2011, a survey conducted by the Las Vegas Convention and Visitors Authority, a government agency, and the official destination marketing organization for Southern Nevada found that 77% of visitors come to Las Vegas to gamble, spending approximately 2.9 hours per day gambling. The United States Environmental Protection Agency reports that secondhand smoke contains more than 4,000 substances, many of which are known to cause cancer in humans. Secondhand smoke increases the risk of heart attacks, heart disease, stroke, lung cancer, and other cancers by up to 30% among non-smoking adults. Casinos include smoking areas, which are the casino floors, and non-smoking areas, which are the hotel lobbies. However, with such high risk, we question how well these establishments do to contain drifting smoke, and if ventilation systems work sufficiently enough to reduce risk for its guests. With that in mind, we designed some questions we wanted to try and answer. The first question was comparing the different casinos. We wondered, do newer casinos have better air quality than older ones? During visits, older casinos seemed to have more of a smoke smell, and the rooms seemed foggier. Do newer casinos possibly have cleaner air due to more advanced ventilation systems? We hypothesized that newer casinos with newer ventilation systems would have better air quality. We ranked the casinos by age, starting with the oldest casino. Next, we wondered about the different areas within the entire building. Non-smoking areas are assumed to have better air quality than smoking areas if ventilation systems can sufficiently contain drifting tobacco smoke. However, we hypothesized that designated non-smoking areas will have similar particulate matter concentrations as in smoking areas. We used portable sensors to measure the concentration of particulate matter with the diameter of 2.5 microns throughout the casino. In the future, we'd like to process the data to analyze indoor versus outdoor air quality and seasonal variation. The overall route was chosen randomly with two things in mind: to include the most prominent Las Vegas casinos in the closest proximity and located on Las Vegas Boulevard. An identification letter was assigned in order of oldest to youngest casino in effort to keep the identities of each casino unknown. The route begins at Casino E, then follows the direction of the green arrows towards the east, crossing Las Vegas Boulevard to head back west and completing at Casino D. Upon entrance, a visit was made to collect measurement points at a designated smoking area and a designated non-smoking area, represented in the figure with a blue or red box. 2 minutes was spent at each microenvironment to collect enough data for an accurate representation of the air. Data points are collected to determine the casino's ability to contain drifting smoke from a designated smoking area to other non-smoking sections, which often allow children, elderly, and other sensitive groups. Distance from the entrance dictated the indoor route. Each casino has a different route based on an overall layout, represented in each box with a line. The closest destination from the entrance was visited first. Each box represents a casino with a specific letter designation, and each X represents a specific location within the hotel assigned by color. The figure is created to give an estimate of distance traveled within the hotel without too much information given on the hotel itself. Data collection occurred over the year of 2019. To account for seasonal variation, 2 days from each season were randomly chosen to collect measurements. This helped us understand if temperature and humidity can have any influence on smoke or aerosol particles.
Hello everybody, my name is Carlos Arambula Quintero and I will be the second presenter for the second half of this presentation. So on this slide here, we're going to go ahead and talk about the portable sensors used for the study. So the air quality monitors that we used were the Nova SDL 607. These air quality monitors measure PM2.5, PM10. They have a range of 0 to 1,000 micrograms per meters cubed and a resolution of 0.1 micrograms per meters cubed. Now on the pictures on the left here just gives you an example of the actual monitor and how we carried them throughout the study. I also do want to mention that we had 2 monitors running for the entire study. We were also interested in environmental parameters, so we used a CO2 meter to go ahead and measure temperature, relative humidity, carbon dioxide, and carbon monoxide as well. We also did track our movements throughout our transect using a German GPS 60. Now the picture on the far right there is just a picture of me and my colleague Marina inside one of these 6 casinos measuring the PM2.5 concentration. Let's go ahead and go on to the next slide. On this slide, I'm going to go ahead and talk about the calibration of these monitors, which was conducted at the UNLV Urban Air Quality Laboratory. Before calibration, we collected all the PM2.5 data from both of the monitors, monitor U and K, and combined it for each trip and casino. Now to calibrate these monitors, we used a dust tract because it shows a good correlation with these types of monitors. The calibration process consisted of placing the monitors in an air-sealed chamber connected to the dust tract and then lighting a PM source such as a candle or a match, and then quickly extinguishing it and sealing the chamber and allowing the monitors to measure the full range of measurements, being from 1,000 to 0. Once the monitor and the dust tract reach the low end range of the data is collected, and it is used to make the following calibration curves. For the curves, we used a polynomial equation because it gave us the best fit for both of the monitors. I also do want to take a moment here to mention the fact that we focused our study on PM2.5 because the human body does have systems in place to partially, if not fully, filter out PM10. While PM2.5, on the other hand, is too small for the human body to filter out, and is why it is a higher health concern and why we focused our study on PM2.5. Okay, let's go ahead and go on to the next slide. So on this slide, we go ahead and look at our first hypothesis. Do older casinos have higher PM2.5 concentrations? So the graphs on the left and the graph on the right are the same graph, with the exception that the graph on the left has a larger scale that goes from 0 to 600 so that we can see the entirety of the measurement, and the graph on the right has a scale of 0 to 60 so we can see the lower end of the measurements. Now the graph on the right, right off the bat, we see that the Casino D has a maximum measured PM2.5 concentration, which is followed by Casino E, then Casino A, Casino C, Casino F, and then finally Casino B. Just by looking at these ranges, we see that there is quite a bit of variability between these casinos, and there's no clear pattern or trend. So let's go ahead and look at the zoomed in graph on the right. Now we do see that there is a lot of variability in the lower end of the measurements as well, so we want to focus our discussion on the median concentrations because we feel that that is a much better representation of the concentration that is within these casinos. So if we look at Casino A, we see that it does have the largest PM2.5 concentration out of the 6 casinos, which is something that we did anticipate given that Casino A is the oldest casino. And for the most part, the trend does seem to continue as you look at the newer casinos, all with the exception of Casino D. So Casino D ended up having a higher median concentration than Casinos B and C, but still had a lower concentration than Casino A. Now, after taking field measurements and looking at this data, I would say that there are other factors that could impact the PM2.5 concentration, such as the number of smokers within the casino, the layout of the actual casino, the ceiling height differences, and the amount of time spent in each microenvironment, such as smoking and non-smoking. I also do want to mention that we are in the process of doing statistical analysis on these casinos to see if there is any statistical significance between these casinos. But for now, let's go ahead on to the next slide, where we will look at the distribution and personal exposure for these casinos. So on this slide, we have the histograms that show the personal exposure of PM2.5 for casinos A through F. Exposure being defined as the integration of PM2.5 concentrations over the exposure time. Let's look at the graph in the top right hand corner for Casino A. The x-axis has the PM2.5 concentrations with bin ranges that increase in a logarithmic scale. The y-axis has the percentage of PM2.5 measurements or exposure. Let's look at the gray arrow there. It is pointing at the gray bar graph, which shows the percentage of the total measurements for each bin, while the black arrow is pointing to the black line graph, which shows the percentage of the total personal exposure for each bin. For example, let's look at the bin that the arrows are pointing at. This bin has a range of 32 to 64, so if we look at the gray bar graph, we see that 45% of the total measurements fell within this bin range. Now let's look at the percentage of exposure for this bin range as well. So out of the total PM2.5 concentrations we were exposed to, 50% of them fell within this bin range of 32 to 64. Now, if we look at the graphs for all of the casinos, we see that each one has a different distribution, not only for the personal exposure, but also for the measurements as well. A reason for these differences could be that the different factors that we mentioned earlier have a role on each casino. For example, the layout of the casinos or the different microenvironments such as non-smoking and smoking areas, which we discuss in the next slide. So on this slide, we have the smoking versus non-smoking areas by casino. So let's go ahead and just take a look at the graph on the left. On the x-axis, we have the total amount of time spent within these casinos, and on the y-axis, we have the PM2.5 concentrations. So I do want to mention that on the previous graphs, we've been combining the monitor data, but we actually wanted to keep it separate on these graphs just so we can show you just how variable the concentrations are within these casinos, even if you are just 3 feet away. So let's go ahead and take a look at the two different microenvironments. So the red box shows you the smoking environment, and then the blue box shows you the non-smoking. So we look at just at the Casino A, we see that the air quality actually is better in the non-smoking areas than the smoking area, and that actually seems to be the case for the remaining of the casinos, and it seems to be even better in the newer casinos. For example, you see Casino F, it is the newest casino, and even in the smoking areas, we do have the PM concentrations actually fairly low in that area, which was actually quite surprising. So that's pretty much what these slide shows you. So let's go ahead and just go on to the next slide. So in conclusion here, I want to go ahead and recap on what we learned throughout the study. So we learned that older casinos seem to have a higher PM2.5 concentration when we look at the median concentrations for each of the casinos, but we also recognize that other factors such as the casino layout, the number of people smoking, and the different microenvironments do play a role in the overall concentrations as well. We also learned that the non-smoking areas do seem to have better air quality than smoking areas, especially for the newer casinos. Now, we do plan to process the outdoor PM2.5 data to compare it to the indoor data, and also evaluate the seasonal variability by looking at the environmental parameters and comparing them to the PM2.5. I just want to give everybody a big thank you for listening, and I hope you enjoyed the presentation.